differentiate 2x squared minus 1 all over x using first principle. So we're going to differentiate this using first principle. Right away, limit as h approaches 0, f of x plus h minus f of x all over h is the first principle. So we're going to plug that into this formula. So we have our function given in question is f of x is equals to 2x squared minus 1 all over x. Okay, this is what they want us to solve, all right, using first principle. So straightforward. So we have limit as h approaches 0 to, instead of 2x squared, write 2 open bracket x plus h squared, all right? Instead of minus 1 over x, write minus 1 over x plus h, then minus f of x, which is the function itself. This is the function 2x squared minus 1 all over x. And everything here is all over h. From this formula, we have this now. We can go ahead and simplify. 2 open bracket. Now this is x plus h squared. That means you're going to say x plus h in that bracket times x plus h in that bracket. And if you expand, that will give you x squared plus 2x h plus h squared, all right? And minus this one. We can open this bracket with a negative sign, minus multiplying 2x squared. We have 2x squared minus multiplying minus here and become positive, all right? All over x. Then we have everything here is all over h. We can go ahead and multiply the first bracket with 2. So this is 2x squared plus 4xh plus 2h squared, all right, minus 1 over x plus h minus 2x squared plus 1 over x. Again, everything is over h. If you look closely, this guy will cancel this guy, all right? So we have limit as h approaches 0, 4xh plus 2h squared. We can say this is all over 1 because the numerator looks like a fraction, okay? Of course, there's an invisible 1 there, plus 1 over x, all over h. Now, when we get the LCM of the fractions in the numerator, we can simplify that further. So let's do it. Limit as h approaches 0, 4xh plus 2h squared over 1 minus 1 over x plus h plus 1 over x. This here, the LCM is x plus h times x, okay? So we can say 1 into x plus h in bracket times x. It's still the same thing, all right? So we'll use this to multiply everything up there. So we have 4xh plus 2h squared x plus h x. This is what you have. Then you come to the next one, which is 1 over x plus h. Now this guy, we'll multiply this, we'll go into this one, all right? So this is gone. We're left with x. So we use x to multiply 1 up. So we have x here, which is negative because of the negative sign here. Then here we'll bring this x into this LCM. So we're left with the first bracket, x plus h. We use that to multiply 1. So the bracket here is maintained. And everything here is all over h. Remember, our limit will always be here, okay? Now that we have this, we can simplify further. Limit as h approaches 0. I can use this first x to open the bracket or to multiply through the bracket. So to say, we have 4x square h plus 2h square x. Then we still have x h here. Then minus x. I can open the last bracket with a positive sign there. Then this is what I have. All over the LCM here, x plus h, x, everything here is over h. Now if you look at the numerator closely, this guy and this guy will cancel, okay? So we have limit as h approaches 0, 4x squared plus 2h squared x, x plus h plus h all over the LCM, okay? X plus h, x, everything over h. Now I'm going to multiply the brackets, the two brackets in the numerator. If I do that, this is what I'm going to have, okay? I'll have 4x cubed h plus 2h squared x squared, right? This guy with this guy, this is what you have. This with this is what you have. Then we pick h now and go this time. We have 4x squared h squared plus 2h cubed x. Alright, this times this gives you this, this times this gives you this, then you bring plus h all over the LCM, all over h, alright? We're going to factor h, alright? We'll factor h in the numerator. Limit as h approaches 0, I factor h here now. I'm left with 4x cubed plus 2h x squared plus 4x squared h plus 2h squared x plus 1, alright? All over the LCM, all over h. Now the h will cancel. This h and this h is gone. Alright? So we're left with limit as h approaches 0 of 4x cubed plus 2h squared plus 4x squared h plus 2h squared x plus 1 all over x plus h all over x, okay? But h approaches 0, so we're implementing that now. So we have limit as h approaches 0. Wherever you see h, you put 0. 4x cubed plus 2, 0, x squared plus 4x squared, we have 0 here, plus 2, 0, x plus 1 all over x plus 0 x. Now what we did here is where we we have like h, we'll replace that with 0. Okay, so these are the places we did that replacement. All right, so if you do that, you have limit as h approaches 0. Of course, this multiplied by 0 is 0, this multiplied by 0 is 0, this multiplied by 0 is 0. All right, so here we have 4x cubed, that's what is left, then plus 1, because all these ones are 0 now. Okay, then all over x plus 0, then you have this is equals to 4x cubed plus 1. X times x is x squared, so this is the same thing as 4x cubed all over x squared plus 1 all over x squared. You can distribute the LCM, and write it term by term. That's what I did. So this x squared will go into this x cubed. You have 4x, okay, plus 1 all over x squared. So this is your derivative. Okay, this here is your derivative.